On occasion, I've had conversations with people where I can't help but think,
You keep using the word. I do not think it means what you think it means.
this might be more of a truism than Monsieur Montoya ever intended. Most words in the English language have more than just one definition, either related or unrelated to a core central concept. Add to that the individual and cultural meanings of words, and what we have is a recipe for unintentional ambiguity and misunderstandings, where two people of different backgrounds could be using the same word in a similar context, but mean something completely different. This is far too often a problem between the scientific community and the rest of the world, and perhaps one of the biggest problem terms is the word theory. A theory in any context is an explanation of how or why the universe or some part of it is the way that it is or works the way that it works. In our day-to-day use of the word, most of us see it as a guess or an untested idea, something that might be true or not. It's okay to believe a theory, or not, because all theories are guesses from people who are just like me, and are therefore equal in value. But in the hard sciences, this is not usually what theory means. One way theory is used is to group all the knowledge of a subject separate from the application of the subject. Already, we can see potential problems with this use of the word theory, if we were to assume that it means an untested idea or a guess. But there's another use of the word, one that has almost the exact opposite meaning of a guess, requiring an explanation to be built on established and repeatedly tested ideas. This is a scientific theory. In order for any explanation to be a scientific theory, it has to meet a pretty specific set of criteria. First, generality. A scientific theory needs to be built on lots of different bits of evidence, and not just a single result or observation. This makes sure that the theory applies in all cases, within the normal statistical variation. Second, falsifiability. While being general in nature, a scientific theory also has to make specific predictions and be testable in a way that could prove the theory wrong. Yes, wrong. In science, it's actually not possible to prove anything right, since getting the results predicted by one theory doesn't exclude the possibility of another explanation. So instead, scientists run experiments to try and get results that aren't predicted to prove the theory wrong. And a theory is only considered valid when no experiment run does. A theory that isn't testable isn't science. Third, consistency. A scientific theory has to be able to explain all relevant existing experimental data and predict outcomes with as good as or better accuracy than existing theories on the subject, because in science, you don't get to pick and choose your facts. These 3 points are the most important when establishing scientific theory, but strong theories usually have 2 additional attributes: adaptability and parsimony. No theory is perfect at the time of its creation, but strong theories are able to adapt to new information with only small changes or extensions while maintaining their core ideas. And at the same time, strong theories are parsimonious, meaning they tend to follow the principles of Occam's razor. When faced with 2 different theories of equal predictive power, usually the simplest, or the one with the least number of parts, more closely matches how the universe works. True scientific theories are the absolute best of scientific understanding. They're consistent with centuries of scientific inquiry and have weathered every test designed to prove them wrong, whether you believe in them or not. They're as close to fact or truth as science is ever willing to state, so as to always leave room for more learning and new understanding. Treating them as a guess is a pretty big misunderstanding. For Tech Laboratories, I'm Tech Adams, saying keep thinking, and thanks for watching. What's been your experience talking about theories? Or where else have you seen confusion coming from different definitions of words? Let me know in the comments below. And while you're at it, subscribe to Tech Laboratories for more videos on science and technology. See you next time! Alternating current, or AC. The voltage of an alternating current looks like a wave, and has a frequency, an amplitude, and a phase when compared to other AC flows of the same frequency. All materials oppose the flow of charges. Jupiter is big. about 318 times more massive than the Earth, and like all things with mass, it exerts a gravitational pull on objects nearby. As New Horizons approached Jupiter, it sped up.